Paul, thank you very much indeed. And ladies and gentlemen, it's now my pleasure to invite Alok Jha, who is the science correspondent of The Guardian, to the stage, where he will interview Paul, and he will also ask some of the questions that have come forward. Alok.
This is on, Paul.
Thanks a lot.
Thank you very much, everyone. Paul, thank you very much for that lecture. It was an amazing list of things we've still got to achieve for robotics, which is brilliant when you're trying to persuade very young people to get into this field, because the questions are all there. These are the challenges. And so what I think I'll do now is I'm going to ask a few questions. Some of you have already submitted questions, as I've got here. I'm going to ask a few questions just to scratch my own itch on these subjects. And then it's over to you, all of you. There'll be microphones going around. If you've asked some questions already on the pieces of paper, don't be afraid to ask them again in person, and Paul will answer them for you. But otherwise, I will also go through some of these questions. So Paul, let me start by asking something that I'm sure most people here probably wanted you to say at the end of this, which is, you've told us about all the problems in getting to a driverless car, but I want to know when I'll be able to sit playing Angry Birds on my phone whilst my car takes me to work. When will that happen?
It's starting now. So you can buy yourself a car that will reverse itself into a parking space.
I've seen those, yeah.
Okay. And so you should get one. And what's going to happen is that then it will start parking itself in multi-story car parks. I'm not going to answer your question. I'm going to get around it. You're not going to have a day where on Wednesday you could buy the car that drives you the whole way to work, on Tuesday you couldn't. Okay? What's going to happen is you're going to get cars, like they always have, that evolve. They'll get better. The technology that we're building has the vision that you let us have sort of like a commercial arms race. And you like the advert that car manufacturer X advertises and says, if you buy our car, the average autonomy time per day in central London is 10 minutes. And then another car company comes along and says, yeah, but in Tokyo, we get average of 15 minutes. And you go, oh, I wonder which one I'm going to buy. And you start buying back your day by buying those extra cost tickets. And by that way, so the cars start driving more of the time. So you're going to get a sliding scale. So I don't think you're suddenly going to get a product that doesn't need the driver or the steering wheel. So I've really, really clearly dodged your question there, because I think it's not well formed. And it's like saying, when are we going to have a thinking machine? Well, you're not. It's going to get better and better and better. And if you can tell me exactly what you want, how many miles you'd want to do, we could then nail that problem. But general driving machines are wild. Is it more a case of thinking that robotic technology, this idea of processing huge amounts of data at once, these lasers, these jazz hands that come out of your car, they're going to be monitoring all the stuff around you. You're still driving, but it might help you to drive better, and then eventually maybe take over some bits of your day, rather than the science fiction thing that you mentioned right at the beginning, where you're just sitting around not even paying attention to anything. That's right. I mean, so you know, you've got to talk about Google when you talk about autonomous cars, and these guys are trailblazers. Let's be clear, and they've gone for the aspirational thing, you know, like shoot for the moon, and we'll try and do the whole thing. It might be worth explaining what Google have done. So Google have an autonomous car that's driven hundreds of thousands of miles, and it's an extraordinary thing. And the wonderful thing about the academic community, and Google's part of that, is that we can all contribute, and the UK can take a really big role here. We're interested in what's the cheapest way you can do this, and we're moving towards doing it with cameras at the moment, so not an expensive system. And I think that, I think you have to think as an engineer, what's the economic model that's going to make this thing fly? And it's going to be like having the cruise control. It's an option that you have that can make your life a bit better. That's not to say you have to have full autonomy the whole time. You can imagine having autonomy in a crash. It's not an area I'd like to research myself, because the health and safety case would be hard. But you know, at the moment, if you slam the brakes on your car, the car kind of says, yeah, okay, get the gist of what you want to do, but your execution is atrocious. What you want to do is slow down slowly without skidding. So who's to say we shouldn't do that with a steering wheel as well? I mean, you can imagine, I don't know if that's a practical thing, but you can imagine that autonomy helping over much of what you do in cars. And it might not be 70 miles an hour in traffic, in a freeway. You never see a car advert, do you, of someone looking miserable in a traffic jam saying your life's better if you buy this car. No, the car advert is always the beautiful people with perfect teeth with the wind in their hair on Route 1. Okay? So we don't have a problem with 70 mile an hour traffic. We have a problem, for me, it's always Earl's Court. I sit there just trying to get through Earl's Court to see my brother-in-law. And that drives me crazy. So I think it's those places that you'll start to see the cars driving and offering you autonomy in low-speed traffic.
Okay. Let me talk about robots in a more general sense as well then. We talk about thinking machines, artificial intelligence, the things that we've been promised from, as you say, from the beginning. Never mind the sort of bad ideas. I'm not talking about Terminators here, but just the really promising things, the robots in the home, all of this, and many of the questions we've got here as well are about the similar thing. What does it mean, though, for a robot to be smart? Because a computer is, in some ways, smart. It can do calculations much faster than I can. It can do all sorts of things more accurately than I can, but it's definitely not cleverer than me. At least I hope not. So what does it mean for a robot to be, or a computer rather, to be smart?
Yeah, and it's a great question. I mean, I think there's a bit of malaise here of trying to say, build an intelligent machine. So I'm not going to work on that problem. If you can't tell me as an engineer what you actually want, I'm never going to succeed. Okay? And so smart machine, I can't answer that question for you because intelligence at what? I mean, for a while we thought chess was going to be really hard. Well, we nailed chess. And for a while there we thought, image recognition, recognizing faces in pictures was going to be hard. We kind of nailed that. But the great thing about those problems, it was clear what success was going to be, like beat Garry Kasparov, be good at chess, was a thing we wanted to do, or be good at finding cats in images. But a generalized thinking machine, I don't know where to start of what that problem is. And then maybe that's because I'm an inveterate engineer. Okay, and the way I think, and I might be completely and staggeringly wrong, okay, we might get a Newton of AI coming along that says, and afterwards we have, oh, I can't believe we didn't think like that. That's possible. Certainly not me. But I think we're going to get to amazing machines by saying, I want a machine that solves this problem for me, maybe a driving machine, or a pick-and-place machine, or unloading a port. And when we work on one of those problems, it's clear what we want to do, and we innovate along that path. We come against problems we didn't know were there, but we're focused. And I'm going in that direction because there's a product or a thing that I want to be able to achieve. And then you accumulate all those things. And that does seem kind of evolutionary. I'm being measured against success in the market, and that's what engineers can do. And so I think, just like computers have evolved because they wanted to be good at supporting games for children, so robots will do the same, and so will these competencies come along. And we'll have lots. I mean, you could not have started and designed graphical processing units just out of the blue. It's because they've been driven hand in hand with the applications of computer games. And I think we'll see the same for intelligence.
I heard a story that, as you say, in the olden days with supercomputers, they would test them with by playing chess. And chess is a fairly straightforward mathematical sort of thing to do. But a real intelligent computer would be able to beat a human, not at chess, but at poker. See, that's the tough part, because you'd have to assess emotions and subterfuge and all sorts of things. Maybe that's not a question for now. Anyway, it's your turn to ask questions.
You could fake it.
It could just try lots of things out, couldn't it? But there's a challenge for you.
Poker.
Your turn now, everyone. I don't know if the house lights need to come up slightly and where the microphones are, but can I just... Can I just see any questions? Anyone put their hands up? Can those lights sort of come down maybe slightly, or the house lights come up perhaps, because they're a bit tense. There's a question there. If we can get the microphone over to there, and then maybe one over here somewhere, if we can get the microphone prepared. Yeah, so the next microphone, if it's just ready for that. Tell us your question.
John Colt from University of Oxford. I've got sorry, I'm going to be greedy. I've got 3 quick questions. One is, for interior location, have you used magnetic fields? Number 2 is anything with fly-by-wire in aviation? And if so, kind of what your involvement or what you think of the current technologies are on those 2? And then as far as general intelligence, to your earlier question, your answers keep going back to, hey, I'm a computer, I solve specific problems. Have you used Google Cards on mobile? And I guess, could you just answer that real quick? And then because I can elaborate on my question.
So there's 3 questions there.
So I'm going to elaborate, hold the first 2, and then I'm going to elaborate on the third one. Have you used Google Cards?
Have I used Google
Cards.
Cards?
Can you explain what Google Cards?
C-A-R-D.
What's a Google Cards?
So basically, what it is it's kind of who's used that in this room?
Wow. You're
Really,
the only
guys?
person.
Okay. So what it is on your mobile device, it may not be out publicly, I'm not sure, maybe it's not, but it's on your mobile device, and what it does is it looks at everything you do in life, and it's a self-learning algorithm, and it'll start recommending things to you based on whatever you've done in your life. So for example, it knows right now that I'm not at home, and it knows that I should probably be going home because it's 8 o'clock and I normally go to home, so it's going to say, by the way, here's a random card for you that it's 21 minutes to home. And then it's also going to say, you know what, Chelsea's playing tonight because I noticed you did a Google search for Chelsea. And it's not solving a specific problem, but what it's doing is it's looking at everything, sensors on your phone, temperature, calendars, different things, and it's going to slowly start.
No, I think it is solving a specific problem. There'd have been an algorithm in there that has a particular goal, and that's to present you with data that's maximum likelihood, or MAP, like what you're doing at the moment, given your previous experiences. That's a thing, okay? And someone would have sat down and said, this thing's going to do these end things, and it's going to be a product. It's not.
It's very linear from a programmatic perspective, but from a use case perspective, it's not. Anyway, then back to my other 2 questions, I guess, so I won't take the rest of
The other 2 questions.
Okay, you asked if I did something with magnetic fields in buildings. No, we haven't. That relies on there being infrastructure. Okay, so we would reject that. You asked if I'd done something about fly-by-wire in planes.
Fly-by-wire technology.
Fly-by-wire in planes?
Yeah.
Well, we use fly-by-wire on the car. So, that's what these things are. They are. The great thing about cars is someone's actually done all the robotics for us, right? They've basically made cars for 6,000 quid that you can buy, and the same for planes. And the thing comes with putting a text file in that makes the thing intelligent.
Okay, well, let's move over to here for the next question. And then if there's any other questions, maybe, how about here at the back as well? But there was a question there first, I believe.
I'm here with my 12-year-old
Great.
son, and he does first Lego League, Lego robotics, and he's done scratch clubs and things.
Yeah.
I'm interested in your comments about the text file and get people programming. What is the path that you see for the next generation, given that the general curriculum isn't really teaching much more than usage of IT?
Right.
Well, that's a great question.
Yeah, I mean, it's really important. I mean, so, I've got, if I'm feeling positive, 15 years left of being creative. It's true. It's you guys. Yeah, you guys have got 40, 50 years of being creative, and we've got to get going on that now. I think we just have to change the curriculum. I mean, the Raspberry Pi initiative is great. And Raspberry Pi's a cheap computer that you can buy. I think it's 25 bucks or something like this, and you just start programming in it. You can plug it into your telly, your broadband router, whatever you want to do, and do stuff with it. Okay, and when we, so I would like, our undergraduate engineers, when they turned up, to be given a Raspberry Pi as well as the tables of data that we give them at the same time. We need to make computing and software everywhere in our education, because it is. We do this for languages, okay, and we do this for maths. We should do it with computers, because, it's hard. There aren't many things we've had in society where we can say, with near 100% certainty, there is going to be ever more of that stuff in our lives, and it's going to be ever more important, and it's computing.
Paul, do you think that schools are set up to do that, though?
Yeah. I don't think there's any real impact. So programming is not magical. Okay. You can write complicated programs and you can write simple programs. I think it's about embracing the sense that we're going to have to do this, and it's not using IT, it's creating it. So I'm really positive about what schools can do, because look what they do. I mean, they teach and they educate. We just need to say, and this needs to be one of the things we teach and educate about, and in universities as well.
Okay. Question from over here. And then who put their hand up? Did someone put their hand up over here?
Yeah, it's just behind the podium.
There we go. And then whilst we're waiting for that, I'd like a question from one of you guys, if possible. So have a think. One of you put your hand up. Be brave. Okay, over here.
How do you feel that society will address the problem of mass unemployment that will be the inevitable consequence of robotic labour?
Very good question.
Is that a problem that roboticists themselves have ever considered?
So do you think about the implications on the workforce?
Yes, I do. And I think about it in a positive way. Are you sure there's going to be mass unemployment because of it? Or might there be many new things that we can do because of it? Because we have machines working next to us. What if they let us do more stuff, okay, that's good, and we're happier because of it? So it's a great question. I think that it's like all technology. Some jobs go, and more jobs start because of it, and the economy marches forward. I'm a positive kind of, some would call me pathologically positive about that kind of stuff. If I felt that robotics was going to make things worse, I wouldn't work on it. I genuinely wouldn't. I make decisions about what kind of things I want to work on, and I think robotics is going to do many, many, many good things. Do I think about the ethical issues of it? Of course. I'm an engineer. That's, we have to do it. It's for society that we do this. But I need help on the ethical and legal side of it. And it's society that's going to own these machines. Okay? If they don't work for us, we won't have them. Okay? We won't buy them. We won't use them if they don't work for us. So they will be regulated. Yes, they will. And there will be insurance. Yes, there will. You could ask, how can you be sure it's not going to hurt someone? We can't, but we'll do the counting like we do on plane wings. We can't guarantee you the plane wing's not going to fall off. Okay? But we will count the number of times it doesn't and say it's reassuring that it does. It's reassuringly low. So what I'm getting at there is there are ethical questions about robotics, and yes, we need to get into those with society, and we need to get into it now, not turn around in 15 years and go, what have these engineers done? Okay, there is a need for it, but we should start thinking about that now.
Paul, as well as the morality around the use of robotics and perhaps, as our questioner said there, how it will affect jobs and society in general, at some point as robots get smarter and more effective in different places, do they themselves need to have some sort of morality built into them? And what does that mean in a digital sense?
If I build a tool, there are quality assurance procedures that I would go through. So if I'm building a welding machine, okay, there are things that I have to check that are safe, and there's engineering process that helps with that. So I think that process for making things safe, because they are tools, they are devices, they are things that do our bidding, is what the ethics of these machines are, because they're not thinking machines. They're not moral entities. They are tools that do what we say. Now, maybe in a science fiction world, way down the line, we say, actually, you know what, this thing's got moral rights. I simply can't talk about that, because right now, I'm thinking about robotics as being a tool. It's a thing that does what we say. And it's a flexible thing, but that's what it is.
Okay. So I'll ask some questions from over here. Okay, go for it. Yeah, at the back there. We've got, I think, about 10 minutes or so. So let's make our question, if you make the questions as short as possible, we'll get more in.
Yeah.
And so then...
I was wondering, you said that we couldn't really make a robot that is capable of everything as in a smart robot, but what if we could make a robot that specialized in like a specific area, such as like household tasks, that a robot that could also like wash plates as well as fold towels and everything? I was wondering, how long in years do you think it'll be until we see something like that in the home?
We're talking about general robots again.
Yes. Right. Let's imagine someone built a machine that completes its interaction. So, every time it touches something, okay, it was either a disaster or a success. If it drops it or smashes it, it's a disaster. Imagine it got it right 999 times out of 1,000. That's an extraordinary piece of engineering. You had that in your home, it would be a disaster. It would drive you crazy, because if you count how many times you touch and do stuff in your house, okay, you have more than 1,000 interactions in a day. And if you broke something in your house, or your machine that you spent a lot of money on, broke something in your house every day, you would not be a happy camper. Okay? And homes have been designed to be good for general purpose devices like us. Okay? And we've been doing that for thousands of years. So here's what I think we'll have. For dishwashers, you have dishwashers. Now, that's a glib answer because there is a case for care for the elderly. I think this will happen, but I think it will happen with specific devices for specific tasks. So you might, if you're in a wheelchair, you might have something that you, as a human, can point at and say, get me that. And that thing gets picked up. I can see that happening. But a general purpose machine in the house, I think, is a long way away. Prosthetics is another thing that I think you'll find you'll have in the home. So people who have limb difficulties, you know, you can imagine having something at the end of your arm, if you're an amputee, that can help you pick stuff up. I can think that. So again, I'm coming back to this case. Be very cautious about wanting a general purpose machine because you can't write down what general is, just a machine that does everything. But instead prefer, I choose a machine or device that nails this problem, and there'll be a market for it, and you know whether it's a success or a failure. I know I keep going on about that point, but I think one of the problems we've had in robotics is promising too much, and a general thinking machine and a general purpose android. Personally, I'm not buying that at the moment.
Okay, there was another question over there at the back, I think. Was that right at the back? There we go. And then, is there any way of getting questions from the gallery, or is there no microphone up there? Does anyone want to ask a question from the gallery? I don't want to leave you out if you've got special things to say. Okay, let's stick to here then. Yeah.
So I just wanted to ask: do you think that the current way that computers compute information with registers and how they store data fundamentally limits the ability to have an intelligent, smart computer?
Sorry, I didn't quite understand your question. Can you say it again just a bit more slowly?
It was a volume thing.
So the way that computers currently deal with information, with registers, with base electrical binary operations, does that limit the ability for computers to act as smart, intelligent beings?
Oh, are you talking about analog computing?
Yes.
And at the moment we wow.
It might be worth just repeating that question for everyone.
So this is, I need to think actually while I'm repeating the question. So he said computers are on or off at the moment, zeros and ones, okay, and it's called binary computing. And his question was, does that limit us in the way that we're thinking? Did I get that right? Did I nail what you said?
Yeah.
Yeah. Okay, so it's pretty clear that this is not a binary device, right? Okay, and this is analog. Analog means continually varying. So I've got voltages inside my head that are going up and slumping at 5 o'clock, but generally, buzzing around. And I don't have ones and zeros, although neurons fire or they don't, but the rate at which they fire is kind of analog. So the existence proof is, yes, it is limiting us. How we would build something, I don't know. I think that's an excellent question. And I'm going to be thinking about that on the way home. So the answer is yes, I suspect it is limiting us. Yeah, no, I've got it. It must be limiting us because that's the only way we're doing it. Okay, and we're not examining other ways to do it. Okay, and to biology, all these options are open, apart from wheels. And that's the the amazing thing about biology is, and there's some really interesting stuff. It's quite old now. Of where they tried to evolve some hardware. So what they had was a whole bunch of transistors that could be connected to each other by a computer. So a massive array of transistors. In the corner is a regular little computer. And what that guy can do is configure the other guys any way it wants. Okay? And it was asked to learn about spotting yes or no. And it designed a circuit by itself, just by randomly trying stuff, and you could see whether it got yes or no right. It was an engineer's dream problem. Either gets it right or it doesn't. And then some engineers looked at what it had come up with, and it was ridiculous. It was like, well, you could kind of spot that this was some sort of oscillator, this was some kind of amplifier, and then there was this whole area over here that was just not connected to the rest of the circuit. So the engineer said, nah, get rid of that. Whole thing stopped working. Whole thing stopped working. And what happened is this independent component up here was using magnetic flux to change some crazy part of the other circuit here that the engineers would never have thought about. But that's because we try and do things in a modular way. whereas biology gets to see the whole of the space of design over time as it weaves its way through. So that's an awesome question. Yes, we must be limiting it. Do I know what to do about that? No. But if the computer guys come along with it, I'll be their first consumer.
Okay, we've probably got time for another question. Oh, there we go, right at the top. Excellent.
Sorry, it's more of a practical question. What exactly is my Raspberry Pi at home capable of?
Can you program?
A little bit, yeah.
Anything.
I'm just like, surely the hardware's got a limiting factor.
Yeah, of course it does, right? But you should, but to all intents and purposes, it's pretty amazing. So, you know, it runs Linux, which is an operating system. You can connect cameras to it, wireless. You can plug it into your telly. It's got a graphics port. I think it's got a graphics processor on it. And you can just download the code and get going with it. And have you got one?
Yeah. Been messing around with it a little bit.
Yeah, mess around. Never stop. Do more this evening.
Okay.
Change your life.
And then go and ask Professor Newman for a job afterwards as well. That's what he wants, isn't anyway. Okay, we've probably got time for a tiny question. If anyone wants to make a point, let's go over here. We've not been over here. You're the last question. Make it a good one. Just wait for the microphone.
I didn't think we could let you go on your trip to London without asking you about money. And I was thinking that you've talked about your frustration and also all the problems that are ahead. And we've seen how the internet caught the imagination of investors and also, to a certain extent, government policy. Do you think something will happen like that with robotics?
The money question.
Yes. Yes, I will. Because if it's going to be useful, and I think it will make economic sense. And the good thing is it's about text files, and software is a thing that's attractive to startups, and the magic lies in the software. So absolutely, this is going to go off. Absolutely, it will. And maybe it's in toy manufacturers, or maybe it's in games, maybe it's in cars, but it's going to happen. I mean, they're going to get, computers are getting better, and with computers getting better, this is obvious, software is getting more complex. With that comes a greater cognitive ability and ability to understand the world. Connect that with some motors and some lights and a few power supplies, a few touch sensors, you have a robot. The machines are coming.
Okay, and on that note, Professor Newman, thank you very much for this, and thank you all for your questions. Can I just invite the Vice-Chancellor back on stage to wind things up?
Ladies and gentlemen, I think you'll agree with me. We've had an absolutely fascinating evening, a real glimpse into the future. Whether it's the near future, whether it's the far future, I guess depends on what you're looking for. I'd like to encourage all of you to carry on those wonderful questions that came up. Please join us at the reception directly outside afterwards and ask Professor Newman more of those questions. Many of his team from Oxford are here tonight as well. They're wearing yellow badges. Do go and ask them about robotics and what their ambitions are for the next sets of experiments. I'd also like to thank Alok for a wonderful function as the MC and teasing out those questions. And also on behalf of all of you, to express our thanks to Professor Newman. We learned a lot tonight. We learned that text files are important, that we must go home and program. We learned about lasers, but I think we also learned something tonight that perhaps we already knew, that the secret to success in life is jazz hands. And so please, ladies and gentlemen, let's thank Paul for a magnificent lecture this evening.